Okay, so this is my Raspberry Pi project, and my name is Wyatt Cortobasi. This is just my table of contents. So for my business case, so the problem was data loss is harmful and costly, and I needed a way to protect it. So my solution was I built a RAID 1, which provides drive redundancy, which is mirroring. So why Raspberry Pi? Well, Raspberry Pi is a low-cost, fault-tolerant storage. And my goal was to demonstrate functional RAID 1 on a Pi, which could be used for maybe small business or for personal uses. So the architecture used. So the stuff that there's several major Raspberry Pi component architectures working together. So the first one I'm going to talk about is CPU architecture, ARM v8. The Raspberry Pi quad-core ARM CPU processes all the RAID subsystem. So it manages m.m commands, handles drive synchronization, and processes file operations. Without the CPU coordinating the RAID logic, the array couldn't assemble or rebuild. So the second I'm talking about is the Linux kernel architecture, which is responsible for low-level hardware control. The MD subsystem inside the kernel handles software RAID operations, manages redundancy, checks for drive failure, and controls rebuild. When my array broke, it was the kernel that detected the degraded state and allowed me to repair it. The next thing I'm going to talk about is the USB peripheral architecture. So my storage drives connect through the Pi's USB bus, the USB controller which handles communication between the Pi and the SATA board. The Pi treated the drives as SDA and SDC respectively. This made my Pi vulnerable when I unplugged them hot, which I learned the hard way and I'll talk about it later. So next thing I'm going to talk about is the next slide is file system architecture, ETX4. So once the RAID array was created, I format it using ETX4. So the file system handles how the data stored, indexed, and retrieved. ETX4 is stable on Linux and works well with RAID. The file system sits on top of the MD device. The last two I'm going to talk about are storage device and the microSD. So my flash drive provides the actual physical storage for the RAID array. Meanwhile, the microSD contains the OS that boots the Pi, loads the kernel, and launches m.m. These two architectures work together, booting from microSD while using USB as a storage array. So the procedures followed. So to build this array, I first plugged in the two USB drives and verified them with the first command on the top, lsblk. Then I wiped the existing partition tables using sudo wipefs space -a. Next, I created the RAID 1 array using the m.m command. So sudo m.m, then create, so it's the third command, and then the RAID level, and then two devices, and then listing the devices that I use, SDNA and SDC. So after the array synced, I formatted it using ETX4, using sudo mkfs.exe and then /dev/md0. Then I created the mount points. So as you can see, I made a mount point there with the sudo fkx4 /mount or mkdir/mount/raid. And then I mounted the array using sudo mount /dev/md0 and then space /mount/raid. So to make it persistent across root roots, I ran a blk id to get the UUID and add it to the /edc/fstab, which you can see the command on the right, or on the right. And then this prevented using the UUID instead of the device name. This prevents issues where drive letters change. So now for the results. So we have videos. Okay, so as you can see, the RAID 1 is active. Those are the two drives. The W just means both are working, and the 2 out of 2 just says they're both working. And got into details. You can see all of it, just RAID 1 system, shows you the sizes of the drives, then shows just the active, that they're active, and they're all working. And we're going to go to the next one. So this is just showing that the RAID is mounted properly. So as you can see, it's mounted to the RAID. And you can see here, when you check, it's mounted all correct. So then we're going to I ran commands like cd mount RAID. This gets us in the place we want, as you can see. And we do echo, and I did RAID, I spelled that wrong, RAID 1 test, and sudo just textfile.txt. And then basically just verifying it. So there we go, RAID 1 test, and then I verified it right here. There we go, it's saved to both files correctly. And then we're going to go to the next one. We're going to enter that. And then there we go, it is mounted properly, as you can see, which is exactly what we want. And then the last thing is testing its functionality when its ones are dropped. So now we're going to do, let's get it, there we go. Okay, as you can see, one of them is currently down, so 2 out of 1, which basically means one of them is not working. So what we're going to do is we're going to... that is the first video, and this is the second video. Okay, so continuing on, we're going to remove the corrupted file. Let me do that. Here we go. It's removed. Now we're going to the next one, and we're going to do add the file again. Here we go. We're going to do test to see if it all worked out. There we go. Recovery right there. Okay, perfect. So we're going to move on from that. So troubleshooting. So I ran into several major issues. So first, I unplugged both drives while the Pi was running. So which corrupted the RAID metadata. So that basically meant I had to redo all the RAID again because I ruined both drives and I had to wipe them again. So the second problem I ran into is the array didn't assemble automatically, and I was having problems with it giving me errors like cannot assemble array and wrong FS type or bad superblock. So to fix this, I had to stop the array, reassemble it manually, and sometimes wipe the drives and recreate the array. Another issue was that my mount failed after reboot because my fsub entry used /dev/md0 directly, which I failed to type in correctly, so I had to redo. So device name changed, so the system couldn't find the RAID. So I corrected this by using the UUID instead, which I found using the command I talked about previously. So, and then finally, I saw errors like device or resource busy. So this happened because the drive still had old partition tables. So that basically meant that I had to wipe them. So the command I used to talk about before was wipefs -A, which solved it. So most of my troubleshooting is centered around RAID metadata errors caused by unplugging drives hot, which resulted initially in having to redo the whole Pi. So lessons learned. So I learned several important lessons. First, never unplug RAID devices while the system is running on the Pi. So software RAIDs rely on consistent metadata is what I've found in being the overall consensus on just don't ever do it. So that was a very important thing I learned during this. Second, always use UUID in fstab to prevent mount issues because then my Pi, I had to redo that. And third, USB flash drives work for testing, but in the future, I would use better hardware like an SSD, which is used in mostly PCs or laptops, or I'd use a SATA hat for more reliable RAID performance. So these experiences will help me design more reliable storage systems going forward. Thank you.